Hi everyone. Okay, this time we're going to take a look at coming up with the equations of at a graph, a trig function, given the graph, and we're going to look at looking basically all four examples here using both the sine and cosine equations. Now, to start off with, when you see the graph here, now you'll notice that I'm looking at only a partial graph. This is only half the period, and that's an important point to note. But there are a bunch of points here that are really important to us. I'm going to make this one down here. This is A. Okay, and then when we go through the middle, actually we'll go right up to the top here. We'll mark this one as B, and actually I tell you what, we're going to hold off on the middle one here in just a second. So A and B here. Actually, hold on. I'm going to zoom out a little bit here so it's a little easier to see. Now, I notice in this case here, and then first things first, that the maximum value is equal to 9. Sorry, and my minimum value here is equal to -3. Now with just those two numbers right there, immediately I know A, okay, which is going to be the max minus the min divided by 2, is going to be 6. Okay, so there's a spread of 6 from the middle to the bottom, middle to the top. I also know the D value, which is the average of those two. Okay, 9 plus -3 is going to be 6, divided by 2 is 3. And that's my median value. Now what I'm going to do with that is I'm going to take and I'm going to draw a line right through the center there, okay, where y is equal to 3. And it's going to give me that point right there, and that's going to be my C point. Okay. Now, I also want to take a good look at this graph here. I know that what I'm seeing right here is half of a period. So the full period is going to be twice this. Now, let's just take a quick look here. Each square that I've got here appears to be pi over 4. Okay? Because if I go from the origin here out to this one this darker line here, that's pi over 4. So I'm going to count this out here. The half period is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so a full period is going to be 16 of these squares. So my period is going to be 16 pi over 4s, and that tells me that my period is going to be 4 pi. Now, B is 2 pi over the period. So 2 pi over 4 pi, and I get right away that B is equal to 1/2. Sorry, I'm right at the bottom of the page here. 1/2. Okay, so now this tells me I can write this out right away here. I know that y is going to equal 6 times the sine of 1/2 x, don't know the phase shift yet, plus 3. Or -6 sine of 1/2, don't know the phase shift, plus 3. Or it's 6 cosine of 1/2, don't know the phase shift, plus 3. Or it's -6 cosine 1/2, don't know the phase shift, plus 3. So those are my four equations. Okay, now the trick is to find out where these things start. And the trick to that is to remember what the period or the initial period of a sine, negative sine, cosine, negative cosine, what they look like. A positive sine starts at the middle of its motion and swoops up. Well, that makes C the perfect starting place for a sine. Okay, it's right along the middle, and from the C value it goes up. So C has got to be the starting point. That is pi over 4 units to the right of the origin. So this thing's been moved to the right here. So to write that in here, I'm going to put x minus pi over 4. Now, the -6 sine graph, that's a tricky one, because a negative sine graph starts at the center, just like this one does, but it drops down. Okay? So I'm not seeing it on this graph. So I got to figure out where it is. Now, when I take a look at this, I know, based on the symmetry of the graph here, that to go from C to the starting point for negative sine is going to be a half period. So that means I'm going to have to go either, a full period was 4 pi, so I'm either going to have to go 2 pi forward or 2 pi backward. Now notice I'm pi over 4 to the right, which means this one over here is going to be slightly closer to the y-axis than this one over here. So I'm going to start from here and go a half period back. Now, I could draw that out, but I'm not going to have any idea really where that is. So what I'm going to do here is take a look at the pi over 4, and I'm going to go a half period back. So I'm going to go pi over 4 minus that half period, which is 2 pi, and I'll do a little bit of fraction work here. Common denominators makes that 8 pi over 4. Oh, lo and behold, the starting point over here must be 7 pi over 4s to the left. So now I'm going to put that in my equation, and I'll put that as an addition, 7 pi over 4. Now that was the hardest one there because it didn't show up on the graph. The remaining two, the cosines, are actually pretty straightforward. We know that cosine, positive cosine, starts at the peak at the top, okay, and that is shifted 5 pi over 4 to the right of the y-axis here, so that's going to look like this. It's going to be x minus 5 pi over 4, and a negative cosine starts at the bottom. It's going to start at a, and I can read this right off the graph. That's 3 pi over 4 to the left. So in here I will put that as positive 3 pi over 4. And those are the 4 trig equations that have the minimum phase shift.